Hello everybody and welcome to another C++ tutorial for beginners. In today's video, I'll be covering sets. Now a set is a data structure that tells us if an element is present or not. That's really the best way to describe it, and in this video I will talk to you all about it. So the best way that I can describe a set in the shortest number of words possible is an unordered collection of unique elements. Keep that in mind as we go through this kind of example here. A set is an unordered collection of unique elements. What that means is that when we use a set, we do not care about the order of elements, we do not care about the frequency of elements, we simply care, does an element exist or does it not? There's a lot of very good use cases for a set, and the reason you would use a set is a similar reason to why you would use a map, because finding if something exists or if it doesn't exist can happen instantly. So unlike an array where, as I described, you would need to look through the entire thing, or unlike a vector where you would need to look through the entire thing because it's an ordered collection of potentially non-unique elements, in a set, the element either exists or it does not. And so to find it can happen instantly. It doesn't matter if the set has a million elements or if it has one element. Now, I want to be very clear here. As I describe this, this is kind of a generalization. There is some instances in which you're using a set or a map, and it will take a little bit longer than instantly to discover if something exists. Now, that is, again, well beyond the scope of this tutorial. I'm not getting into lower level implementation of C++ built-in features, but just understand that all of this is a very general way of looking at this. As you learn more about computer science and C++ and programming in general, you will kind of realize how these things actually work beyond the level at which we're using them at. Anyways, with that said, let's get started here. I'm going to include set. So include set like that. So let's make a set. When we make a set, what we do is we say set, we do our angle brackets, we do the type. In this case, I'll just make it, actually, let's make it a char set. And then we do the name of the set. So I'll say S1. Now, if you want to initialize the set, I'm just looking at my kind of cheat sheet here. Actually, it doesn't even show what I can do. Let's just try to initialize the set by adding some characters like C and D to it and see if this works. All right, so when I run this, no problem. So this kind of confirms my assumption that if you would like to create a set, what you can do is put all of the elements that are in the set just in curly braces like you would in an array, and you can initialize it that way. Or you can declare the set by simply doing set, the type, and then the name of the set, and well, that works as well. Anyways, let's add a few duplicate elements into this set, and let's iterate through this set, and let's see what elements are actually in it. So I'm going to say for, and I'm going to use kind of that iterator pattern we've seen here. So I'm going to say auto S1 is equal to, sorry, not S1, auto ITR is equal to S1 dot begin. And then I will say ITR does not equal S1 dot end. And then I will say plus plus ITR. Now, again, remember, a set unordered collection of unique elements. And well, that means we are not sure what order we're going to get elements in when we loop through the set. And so this kind of means nothing when I write like this specific ordering of elements. Just keep that in mind, okay, that we don't know the order of elements in a set. Then what I'm going to do is say cout asterisk ITR and end L, and let's see what we get. All right, so we get C and then we get D. Notice I didn't get CD, CD. I didn't get CC, DD. I only got one C and one D. And that is because when you insert an element into a set that already exists, it doesn't do anything, because we only care if something exists or if it does not exist in a set. That is really the purpose of using it. And if I decide to add maybe an A here, and we run this now, notice we get ACD, even though A was at the very end of the set, so we don't really know what order we're going to get elements in, although this might make you assume that you're going to get it in alphabetical order. Anyways, that is a set. So hopefully that's clear on the basics of a set, and I'll kind of leave this here so we can see what happens as we insert and remove elements from the set. So to insert something into the set, you can say s1.insert, and then you can just add whatever you want. So maybe we'll add a B or something. We can run this now. We see all is good. A B has been added in, and it's kind of confirming our assumption that it's probably printing out in alphabetical order. Anyways, we can also erase or remove an element from the set. So I believe it's actually erase. Let me look here and see if that is what it is. Where's all these methods? I have a list of all of the methods. I think that erase. Yep, erase looks good. So we can erase maybe the key C or the element C. So when I do that, notice that now C is no longer printing out. And so that's kind of the most basic aspects of a set. That's how you insert. That's how you erase. And well, this is how you iterate through it. Now, a few other things we can do. We can check if an element is present and say if and we'll say s1 dot find, and we will look for some element. Let's say we're looking for element C. We can say if that is equal to s1 dot end, that means the element does not exist. So I can see out could not find C, and we can do an end L, and then otherwise we can say C out and found C exclamation point, same thing, end L. Okay, so let's run this now, and notice that we're getting could not find C, ABD, because, well, C is not in the set, and so this, same way as in the map, is telling us it's not there. If we look for a B, well, actually, we did C, so let's just not erase C now. So if we don't erase C and we run this, it says found C. It's telling us C is in the set. Okay, so that is really that's pretty much it for a set. Now let's just run through a quick example here. And just like I did with the map, I will create a string. So let's say string test is equal to this is a test, I, whatever, a bunch of random letters. Okay. Now what we're going to do is say set char occurrence is equal to, and actually we can just do it like that. We don't need to define or initialize it. And instead of occurrence, let's just make it easier. Let's just say exists. Okay. Now what I'm going to do is loop through the string. So I'm going to say for, and we could use a string iterator here too, or we can just loop through it in the way we normally do. So I can say int I is equal to 0, I is less than test dot length, and then I plus plus, or again, just because I think this is the proper way, we'll go plus plus I. And then what I will do now is say exists dot insert, and we will first define the letter. So we'll say char letter is equal to test at I. Now notice we don't have to do this. I'm just doing this because it's kind of good programming practice to define what it is you're actually inserting and kind of make it easier to read. But you could just put test I in here. Like you could do test I without defining the variable first. But for me, I just like to define the variable. So I'm going to say letter, and we'll insert that into the set. So now what we've done is we've looped through the string. We've inserted every single element in this string into the set. Now I want to look at all of the unique elements in the set. And so what I'll do is say for, and then I will loop through the set. So I will say, what is this going to be? Auto itr is equal to exist dot begin. I'll then say itr does not equal exist dot end. And then I will say plus plus itr. And then I will just, C out and asterisk itr, dereference, and L. Okay, let's run this. And what we're getting now is all of the unique letters, including the space that is in this string. Now, it doesn't matter if I add like a ton more A's, we're not going to get another A here because, well, it's a set, right? And so if we add A in again, it doesn't do anything because it's already in the set. So there you go. Now we can do actually a quick example here. Again, this is kind of another thing you might see in a coding interview. Speaking of coding interviews, if you guys want to prepare for them, you know what to use. AlgoExpert, which is a sponsor of this video and this series. They have over 150 coding interview questions, many of which use sets, dictionaries, and a lot of things we're talking about here. Check out AlgoExpert from the link in the description and use the code TechWithTim for a discount on the platform. Anyways, good segue there. What we're going to do now is I'm going to create another string. I'm going to say string find is equal to, and then I'm going to say, let's say the word hello. Okay, so let's say we were given a problem and we were said, okay, you're given this string called find, and you want to determine if all of the letters in this string are also present in this string. So you want to see if all of the unique letters here are also present in this string right here. There's a few different ways to go about doing this, but using a set, we can do this kind of elegantly. We can create a set that stores all of the letters in this string that we're trying to look for. Then what we can do is loop through this string. We can remove all of the letters here from the set that contains the letters in this string. And if at the end of going through this entire string, this set is empty, that means that this first string contains all of the unique letters that are in this string. Hopefully that kind of makes sense, but I'll just run you through it and we can see how that works as a good example. So I'm going to say set. We'll say find letters like that. So now we need to go through and essentially add all of these elements into the set. There's a few different ways to do this. There's some shortcuts as well, but we're just going to do the long way because it's good practice. I'm going to say for int I equals 0, I is less than find.length plus plus I. We'll then say char letter is equal to, and then this will be find at I, and then we will say find letters, find letters dot insert, and we will insert, what is the letter? Letter like that. Okay. So now if we were to print out all of the letters in this set, we would get H, E, L, and O. So now we want to go through here and see if this contains all of the same letters that are in here. So what I'm going to do now is say for, and we'll say, I guess int I equals 0. I is less than test dot length, and I plus plus. We'll say char letter is equal to test at index I. And then what we will do is erase this from the set. So we'll say set dot erase, and we'll erase letter. Okay, great. So then finally, what I'm going to do here is write an if statement. I'm going to say if, and don't worry, I'll go through all this code in a second. I just want to type it out first. I'll say if the find letters dot size is greater than 0, then that means cout no, it does not have all letters. I know it's not really great English, but you get the idea. Else we can cout yes, it does. Okay, great. So anyways, let's just quickly run this actually, and let me see if this works. Warning, character constant. Oh, I forgot about this. This needs to be double quotation marks. My bad. And missing template argument before dot. Oh, I don't know why I called this set. Look at how many errors I have. I need a semicolon there. This isn't set. This should be find letters. Let's run this now. And there we go. No, it does not have all of the letters. And so that is working as intended. Okay, let me run through all this code. I know I went through this pretty quickly. So the idea is that we were asked, all right, we have this find string. We have this test string. We want to see if all of the letters that are contained in find, unique letters, by the way, are also contained in the test string. And so what we do is we first create a set. We call it find letters. We then add all of the letters that are inside of this find string to the set. That's going to automatically handle not having like duplicates and anything for us, because if we add two L's, it's just going to be one L that remains in the set. Then we go through the second string. For all of its letters, we remove them from this set, because then that means if we remove every single element from this set, this string had all of the elements that were in this string. If it doesn't, though, if this set does have at least one element, that means that we did not, right? Like we did not have all of the same letters. And so in that case, we would print out, no, it does not have all the letters. However, here, the letter that we're missing, I believe, is an L. Might be missing an O too. Yeah, we are also missing an O, but we have an E and we have an H. So now if I add an L and an O in here and we run this, we should see that it says, yes, it does. It does have all of these same letters. We can even make this a bit simpler. We can make this string say like this, like hello with only one L. And we'll see we still get, yes, it does, because even though it doesn't have two L's, that doesn't matter. Although if we remove the O, it's going to say, no, it does not have all the letters. So this is an example of where you might use a set. Of course, there's a lot of other examples, but hopefully that kind of brought everything together for you. And again, I'm trying to do some longer examples here so we can see how we actually solve problems with all of these tools that we now have. Anyways, if you guys enjoyed, make sure to leave a like, subscribe to the channel. I will see you in another YouTube video.